Welcome to this lesson that deal with climate change negotiations starting from Rio de Janeiro till the latest COP in Belém, and we try to look to make an overview of this climate change negotiation, but keeping a focus specifically on the forest systems. So here you have the slides. So if you prefer looking at the slides, they are here. And I want you to focus that as a note, as a quote, I like this one because really highlight has sometimes is not you run out of resources that change things, but you have better things, better innovations that are able to provide better services for the society. I think this tell a lot about our story about fossil fuels. So about myself, I am a forest and natural resource economics. I work at the Bureau d'économie théorique appliquée of Nancy, France, and I am employed by the Ministry of Agriculture of France. So I have a master in forest and environmental sciences, and then a PhD in agricultural policies. And my work really involves a lot of simulations. First about agent-based models, then about forests, switched from agricultural to forest, and dealing with bioeconomic models, and more recently I'm doing a lot of machine learning algorithms. So my research involves a lot of climate change and the interplay between the forest resources, but the forest sector more broadly, and the climate change. So how forest is impacted by climate change, forest sector is impacted by climate change, and how also climate change, forest sector can play a role eventually on climate change mitigations. And I am involved in several projects that deal with more or less with this on different aspects of this two-side connection. So I am here really, if you want to say who I am these small dots between this forest, climate change, economics, and also modeling and simulation, as I do a lot of them. So why is to speak specifically about forests? What particular in forest when we deal with climate change? We'll make a short introduction on the role of carbon, climate change, and forests, how they connect each other. And again, we'll see how the forest sector can eventually help on climate change issues, and what's specific of the forest sector. And because we cannot understand the present if we do not look back on the past, we'll surely look at the current level of the climate change negotiations. But this lesson go a little bit on the history of these negotiations, where they started, how we arrived at where we are now, and why climate change is an international issue. So we want to keep the overview at the international level. We also sometimes go down to the EU implementation, so how climate change negotiations are implemented in Europe, and this for different reasons. The first one is that what happened in Europe on an environmental point of view often has an impact outside Europe in terms of environmental standards, in terms of regulations, because sometimes the standard itself, European standards, is copied in other countries. To make an example, in the Philippines, for example, they are using for pollution, for car pollution, a standard with the Euro 4. Now in Europe we are at the Euro 6, but the point is that they didn't invented or created from scratch their own standard. They got the European one because it's the first one that has been developed. Then it's possible that sometimes policies that are designed for Europe have an impact outside Europe. For example, policies about biofuels have a spillover effect and make how to say change the behavior of agents outside Europe. For example, in Canada, that export fuel woods to Europe, and sometimes policies designed in Europe has a more global effect because they directly influence what happens outside Europe. I'm thinking about illegal logging. Illegal logging for tropical forest is not concerned, is not the focus in Europe, is a policy that is in Europe but extend territorially on other regions. So for all these reasons, I think it's important to have a look on the international climate change policies, but also look how these are implemented in Europe. So if you don't want to retain anything of this lesson, just keep in mind this curve, okay? So at the end of this lesson, we'll understand what this represents, what this axis represents, and what this curve means. And by the way, at the end of the lessons, we'll have some quizzes, so stay tuned, and these quizzes will help you to realize if you understood the topic or if you need to rewind the video and study a little bit more. So let's gonna make just a preamble. Where are we? So climate change issue is something relatively new, but it's not the first issue that deal with fossil fuels. And it is interesting to see that we already had issues with fossil fuels before climate change, but the issues was different. The idea there was this peak oil theory that there weren't enough fossil fuels. So here in this chart, I hope you can see it well, you have the price of a historical price of oil. And you can see for many years this price has been constant, a little bit going down, but very, very constant. And suddenly at the beginning of the 70s, it jumped very high with two shocks at the beginning and at the end of the 70s. And you can see here that when you have a shock in the price, you also have this color in gray are years where you have a depression. So there is a strong link between the price of oil and recessions. And you can see that after this period, we had many other periods of high volatility of oil prices. So you understand that when we were in the 70s, it has been a very big shock because it was something really uncertain. Now we know that oil prices are very volatile, but at that time we was experiencing very constant prices, and suddenly this price started to be volatile. So the problem was that people started to believe that as fossil fuels are a non-renewable natural resource, these fossil fuels were coming to an end. And there was really the fear of depletion and reaching the peak of production and starting to the resource to get exhausted. So the idea of peak theory that itself doesn't, the most most famous example is for fossil fuel, but more in general it refers to any non-renewable natural resource, is that production curve of a non-renewable resource take a bell curve, and then according to this theory, when you reach the peak of the curve, production rates starting to decline because the resource start to decline. And you can see here was a big shock. Here this photo from US, but these were true in all the world. And if you are curious, if you get a fine for overspeeding recently and thinking that overspeeding fine has been added for security, for safety, to improve safety on the road, actually no. The first first speed limits has been introduced during this period of the 70s in order to reduce the consumption of oil, because a car that goes slower consumes less oil per kilometer than a car that go very fast. So blame this oil crisis if you has been catch with overspeeding. So again, so this is the theory. So the curve here in green. So here is time. The curve here in green is the production of oil in the US, I think, and you can see here that it peaked in the 70s, and then due to scarcity of oil, and not necessarily physical scarcity but also geopolitical scarcity in that period, and the several crises in the Middle East, we had a decrease of productions. So you can think here, you are here, think historically, try to think you are here in the 80s, and you observe this curve. Well, it comes naturally to make an assumptions that, hey, we are having a bell curve here, and so you start making the hypothesis of this peak oil and in irreversible level of scarcity of oil. But very often when you make a model based only on data without really having behind it some structure of your model, you risk. And you can see here that you risk because then there has been other technical innovations, and so just after you made this hypothesis, these two curves, the theoretical red curve in here and the empirical one in green, started to diverge. So it's always risky to make conclusions only on empirical observations on inductivist. So there is a little bit story. I don't know if I should tell you here in this recorded lessons of the inductivist Turkey. So in this story is this one. So there was a Turkey in that where there were a turkey that were fed so every day. So he was scared at the beginning, seeing this guy coming too close to him. So he was really scared at this turkey, but then one day he received food. Second day he received food. So whatever was the season, whatever was the weather, nice weather, bad weather, he started to not be afraid anymore about this guy that was coming to feed him, too close to him, because at the end he realized, okay, I'm an inductivist turkey. I'm making in my by observation, seeing that this guy is helping me, is giving me food, so I'm starting to be relaxed. And then it came the Thanksgiving day, and the guy didn't feed the turkey, but I stop here. So the idea is you look observations, but the observations of the past are not conclusive if you behind don't have a model that explain them what will happen in the future. Okay. So let's go back to our slides. So this rised at the beginning of the 70s. Lot of fear about the economic growth being constrained by the natural resource, finite natural resource, non-renewable natural resource. And here I'm putting a very important, that had a lot of consequence in the theory, in the thinking of environmental economics, the limits of growth of the Club of Rome in 1972. And I suggest you to have a read about that, because it has been very important, and really highlight what was the thought in that period, even if the main issue with this one, so this has been obtained by the first computers that were starting to appear in that period, but you didn't have enough feedback and enough economic on models there to counterbalance the feedbacks. So what is the status then? Did we have the scarcity? Well, there is something interesting here. So here say by each year in time which has been the fossil fuel reserves. So you can see here for gas, we start to think here in 1980 that we have 50 years left of gas reserves, and then after we go over 50 years, we still have 50 years left. And if for oil, it's even increasing. So we start to think we have only 30 years. In the 80s, we was thinking that the no reserves of oil were only 30 years. And then instead of, even with consumption, and we see even with an increasing consumptions, these reserves increase with time. And if you take coal, is even higher. So actually, we don't have this problem of scarcity. We are not run out of fossil fuels as we weren't run out of stones for the Stone Age. We need to change, even if fossil fuels is abundant, is everywhere on Earth. And the problem, we're starting to realize that the issue is not a problem of scarcity of fossil fuels. So this is a fundamental curves that I would like to highlight. This highlight is that something else. So these curves that here is started in 1958. A guy in the middle of the Pacific Ocean in Manualua Atoll started to measure the concentration of carbon dioxide so it's the first one that constantly every day started getting the concentration of CO2. So the concentration of carbon dioxide on the atmosphere, it has some seasonal pattern between winter and summer, but you can see here that started in 1958, and then gradually every year is this carbon dioxide concentration increased, and now we are around 400 and something. So this was new at the time, it wasn't expected, and was really the first things that raised the bell. Okay, we have a problem with fossil fuels, but fossil fuels is not scarcity, it's something else. And here is the emissions from fossil fuels in the world, and you can see here that actually these emissions never peaked. We had some cases during the COVID, some cases when there were some temporary reduction where there was an economic crisis, but they were very short-living, and the trend is pretty linear, pretty constant. Okay, if you want to be a little bit more optimist, instead of looking the total emissions, we look at the per capita emission, and this tells us something that if in the 60s and 70s these per capita emissions increased, but then starting already from the 70s we were able somehow to do something pretty remarkable, because our economy is not the one of the 80s. It's increased a lot. The world economy increased a lot from the 80s. Still, the per capita emission remained more or less constant, increasing only a little bit. So we have some negative message here that emissions are continuously to increase, but we also have some positive message, because these emissions are clearly led by the population growth, and population growth is something that is very quickly stabilizing. So if you look on the long-term perspective, it's clearly that this emission has to start peaking. Because population also is peaking in the world. We are reaching a peak of populations. However, the problem that we'll see later is that this will happen relatively very far in times, and perhaps we don't have this time to wait for this natural peak of emission, and perhaps peaking the emissions is not enough. Maybe we need to drop the emissions. So what happened when on the emissions? There are two ways who contributed the most on these emissions. There are two ways to allocate emissions to different countries. The classical one, the one that is used in the climate change negotiation, the one that is mainstream, is to simply allocate the emissions where they are made. So if you take this one, we call this production-based inventory or allocation. And if you look between 19 and 2009 on the country, we can see that Europe did well, decreased their emission, not the per capita, the total emission. Europe were able, and the US did bad, but not so bad, because less than 1%. Who really increased the emission is China and India. Okay. However, there's another way, that is the one of consumption-based. And if you do consumption-based, we allocate emissions to the country where the final good that has been produced following that emissions has been consumed. So if China, for example, make emissions to produce a laptop, and then or a phone, and then I buy the phone here, and I am in France or in Italy, then the emissions to produce this phone here are allocated to France or Italy instead of China. So you can see here a different picture emerge here, and the developed countries, when we measure the emission in terms of consumptions, they are not doing so well as for production. This means that they simply delocalize their polluting industries to developed countries that indeed they decrease their emissions when we move from production to consumption, both for China and a little bit less for India. And you can see that so when we say Europe has been very good, very top of the class for reducing the emissions, we always look to this a little bit skeptical, because actually we are still responsible of a large part of emission in the world. Just we don't do them, we delegate them to developing countries. So we speak often about fossil fuels and carbon dioxide. We don't speak much about other. They are not the only greenhouse gases. They are not the only gas, but when they are emitted to the atmosphere, they have an effect of greenhouse, making the earth more warm. There are other gases. Here there is fluorinated gas, there is nitrous oxide, there is methane, and then there is also carbon dioxide, but doesn't derive from fossil fuels, but here in blue, but derive from change in land use, so deforestation typically. And what we observe here, however, is that while these four elements remain more or less constant, the one that really increased a lot is carbon dioxide from fossil fuels. So, or if they increased a lot, but they remain very marginal, like fluorinated gas. For all these reasons, the main issue that has been worked on for climate change negotiations, in climate change negotiation, is carbon dioxide, and for a large part, not only, but for a large part, is carbon dioxide coming from burning fossil fuels. The role of the forest here is clear, is here, but stay with me, because even if the main we want to see why the negotiations deal most with fossil fuels and very little with forests, and how forests can be can play a role even if the problem is fossil fuels. So this chart shows the increase of temperature. So up to the 60s we had the climate relatively stable, and then we had a very large increase starting from the 70s in temperature. So we saw that forest. So one important things, climate change. We saw earlier the chart on carbon dioxide in the atmosphere, the concentration, and now we saw a chart on temperature. You may want to ask, is this the first time that Earth had this level of carbon dioxide concentration? Is this the first time that Earth has had this level of temperature? No. If you go enough back in time, sorry, I didn't put the slides here in the recorded video. If you go back enough in the time, you will see period where the Earth planet has been much warmer than now, and period where the Earth has been with much higher carbon dioxide concentration on the atmosphere. So what is new? What is really dangerous? What is really new is the speed of change. When the Earth became very warm, when the Earth became very rich in carbon dioxide concentration, this happened in geological times. This happened in millions, in hundreds of millions of years. Now the same phenomena is happening at a human time scales, in terms of centuries or even in terms of tens of years. And this is what is unique and what is extremely dangerous, and what to give no time to natural species to adapt to this very quickly changing world. So you saw that we saw some charts that the temperature are increasing, emissions are increasing, so nothing seems to work. So how can forests can help? We'll go in deep to the Paris Agreement, but you can see that I can already start telling you that the climate change Paris Agreement in 2015, we were in a period where a lot of things didn't work. We had before it Kyoto, we see it. We had several attempts to deal with these issues, but nothing really worked. So we arrived in Paris in 2015, where the society was really, I don't want to say desperate, but that is the idea. And then suddenly we got back the forests, and this need of remove, there has been really highlighted that the absolute necessity of remove climate change from the atmosphere. And the Paris Agreement is a very small document, it's 15 pages if I remember, and it extended about 30, and with an X, and it came 9 times the word removal. So much is stressing, and of course, how can you remove quickly carbon from the atmosphere? Well, planting a tree, for example. So this idea of forests that must help suddenly on something else is nothing new. So here I'm putting a law when there was the Kingdom of Italy in 1923, and just to tell you that even at that time, there was this idea of forest as something that can be used to solve problems that weren't for related to forest at all. At that time, the issue were hydrological issues, flooding, and hence the forest was thought, okay, we can use forest to make the mountain soil more stable and avoid flooding on the bottom. Then we had other in the history. I know more about Italy, but I'm pretty sure this happened in many other countries. During the after the Second World War, there were a period of highly unemployment, and so you want to give jobs to people, but you don't want to give money for nothing. So let's say, which job can we give to people? Well, let's gonna make them planting a tree, so they have a job planting a forest. So again, there's been a disaster. The forest that has been planted in that period weren't really adapted to the environment. They weren't adapted to the needs of the society. But that wasn't really the scope. There was a policy where the forests were just an excuse used to do something else, to provide a job, because the policy was about solving the unemployment issue. Again, another very common example is in the 80s, common agricultural policy. The price of there were a surplus, a structural surplus of many agricultural products, and so the price were going too low, and so there was a way to support the price to farmers that were to take some product and destroy product. I still remember on the news this is a video of oranges being destroyed to keep the price higher, and of course politically it wasn't very nice. It wasn't easy to justify this. So someone came out with the idea, why instead of destroy agricultural production, we give money to plant trees, because if the land will bear forest, we can reduce the agricultural surface, we can reduce production, so our farmers can be happy, but the price will be high. So again, it doesn't matter what you plant a tree. I'm not caring about forest, I'm caring about another issue that I have. And I believe that now the situation is very similar. We have a very strong issue, very important issues of climate change. So why not to use forest to solve the issue? So forest sector will save the world. This is something that happened recently, relatively recently, with the issues of climate change. But I would say, because I love also Spider-Man, put attention, because with great power came great responsibility. So something could not work, and in case of that, forest sector will have a big responsibility, and it's something dangerous. Okay, so we can go to our second part after this introduction, and see how forest sector can help climate change and how forest sector is impacted by climate change. So I would like to start by fixing some vocabulary and have a clear definition of hazard, exposure, and vulnerability. So if you recall it, hazard is simply the probability that a potential source of harm or danger may arise. So it's the probability that something that could be dangerous come. It's not the risk itself, it's the probability that this possibly dangerous event may come. This is not enough to have a risk. You also need to be exposed to this event. So the exposure is the extent of which arriving, conditional to this event arriving, you are exposed to it. And this is more easy to think about that. For example, if there is a tsunami, your house is on the coast or it is something on a hill, more protected. If a draw arrive, are you in an area where you have the draw is impacting, or you are somewhere where you have a deep soil or you have a proximity to water resources? And finally, even if the hazard come and you are exposed, are you vulnerable? So conditional to this this event coming and you are being exposed by the hazard, are how much you are affected by this, how much is the impact of this event to you, so how much ready you are to protect yourself from this event. So you can see that risk is really the likelihood of damage. You can think about the multiplication of this probability. The first one is a probability and the other one being conditional probability. And here we have two things, mitigation and adaptation. So mitigations is something we'll see in details in the next slides, that try to reduce this hazard, try to reduce climate change, it try to reduce the probability of climate change, while adaptation is something that deal really with exposure and above all on vulnerability. So if climate change arrive, how ready I am on to reduce the risk on that. So to take some formal definitions, climate change mitigation is reducing the net flow of greenhouse gases into the atmosphere, and the objective is to stabilize greenhouse levels. And again, here you see that the time frame is important, at the time frame sufficient to allow ecosystem to adapt. So again, the issue of the speed of change is very important. Mitigation try to if not to avoid change, to slow down in a time that is sufficient for ecosystem, but also for society to adapt. And how can you reduce the net flow of greenhouse gas in the atmosphere? Well, there are two ways. You reduce the flow of gas going to the atmosphere, and doing this one, you can try to improve the efficiency of your economy, so have more gross domestic product per unit of energy that you use, or you can change the unit of energy that you use to something that doesn't depend on fossil fuels. Or when related to forest, you try to reduce deforestation or reduce the degradation of the forest itself. And sometimes you can think about other measures like reducing methane and perhaps change alimentation habits. You can also try the opposite, but improve carbon removals from the atmosphere. So what we saw in the Paris Agreement, this stress as this one didn't really work a lot. Now in 2015, there has been a big stress on trying to improve the removals of carbon from the atmosphere. And the quickest way, of course, is land use methods, in particular reforestations. I would like to say other ways are not proven, so you may hear a lot of carbon capture and storage. However, it's something that with the technique of today, the technology of today is still very expensive and also energy intensive, so it's not something that is practical on a high scale. On this one, I would like to stress that I am basically an economist, and it's important that you have a model that you consider technological progress. However, technological progress in general is something that it's justified to add to your model, to think about that, to consider that. However, one specific technology is always very risky. put your bets on one specific technology, whatever it is, in this case carbon capture or storage, or clean nuclear, or other technology, it's always much more risky than consider technology as a whole. And the other one is climate change adaptation. So climate change adaptation, it tries to reduce your vulnerability to climate change, considering that some climate change by now is inevitable. So he will come. We already have actually climate change. So how can we reduce the social vulnerability, and how can we exchange ecosystem resilient? I would like to stress you somewhere it's here. So it's not only reducing the risk, but is also making the most of any potential benefit, potential opportunity that we may have of climate change. So climate change, of course, has a lot of negative impact, but there are some positive impacts localized in the world. Well, if you are speaking here English, perhaps you are from Britain, you will be delighted to know that you can have very good wine now in England. They cannot call it champagne because champagne is the name reserved for France, but now you can start to grow wine in England. Or I am Italian. I'm very happy. I love coffee, but we can have a coffee now that is planted in south of Italy. Or perhaps you like to buy things remote, and one advantage is that the North Sea route will be much more accessible than today. So it will take shorter and will be quicker and cheaper to have intercontinental transport of goods. Perhaps you like to be tourist in the North area, and again, something positive is that climate change will increase tourism in Nordic countries because it will be more accessible and more easy to go there. So you can see all these things, that is not only negative aspect of climate change. However, we do have some trade-off about between mitigation and adaptation, and more we are starting to see that we cannot consider mitigation and adaptation independently. So in other words, we would like to mitigate climate change, but because climate change is here, is arriving, we also need to adapt at the same time. And this becomes difficult because we can no longer mitigate as much as we would like, because we have also to consider the need of adaptations. And this is very clear in the forest sector, because, for example, here we like to mitigate climate change in the forest sector through sequestration. We'll see later what is it. We should use fast-growing coniferous species. However, these are also the ones that are most impacted for climate change. So we can see that we can no longer use this strategy as easily as we would do without climate change. And here it's another example from nature that increased energy use for adaptation, and you can see here a photo of air cones, will impact the mitigation pathway because we will require more energy. There are other trade-offs that should be considered. One about equity and efficiency of the politics. Perhaps we want to make politics that are efficient, but those that are more efficient are not necessarily those that are more equitable. About equitable means we mean the effect on the population, so the diverse effect that this policy may have on population. Perhaps this policy that are more efficient will make suffer the pain the most are those that are more poor, and is completely unacceptable. So we have a trade-off between making some policy that perfect are not very efficient, but are more equitable than other that are more efficient but less equitable. And another trade-off is related to the timing. Where should we start to do actions? This is clear, for example, for assisted migration of species. We want, for example, to use Mediterranean species more at the north because these are more adapted to warming weather. However, we don't know exactly which species, we don't know exactly what we are coming, so we risk to do something that is called maladaptation. So if we don't wait, we do act now, quick, on adaptation, we risk to, because we have only a small set of information, we risk to do our adaptation badly. If we wait, we bring the cost of inaction, because more we wait, more the chance, more will be expensive to adapt, more will be heavy the cost of the adapting, rather if we do it just now. So we have this trade-off of timing. So how forests can help? So fossil fuels, we see here they are increasing, they go to the atmosphere. So this is the source of carbon dioxide. As we said earlier, land use change are relatively constant, and burning fossil fuels is the main issue and is increasing issues. So this is what go to the atmosphere, okay, with time. Not all carbon that go to the atmosphere remain to the atmosphere, but a large part is absorbed by ocean sinks and land sinks, and only those that is not absorbed end up to remain in the atmosphere. So you can see here that land sinks depend a lot of the year. Ocean sinks is much more homogeneous around the year, but you can see here that not all go to remain to the atmosphere, and how much of this carbon remain to the atmosphere? Well, more or less is 50%. What is this chart? This chart represents the main reservoir of carbon on Earth. So here most of the carbon is in the oceans or in the lithosphere, where there are the judgment of fossil fuels, and some carbon is in the atmosphere and something on the terrestrial biosphere, including agricultural area, forest, and so on. So these blue arrows highlight the exchange between one reservoir and the other one. So naturally, we have this number this number in black that are in a petagram of carbon, and you see here something in red. Okay, what do you think is this? What do you think is this 0.1 and this 7.8? So the 0.1 is the carbon that naturally go from the lithosphere of the atmosphere. It is very small. It is the effect of volcanism mainly. And this 7.8, well, is the humans that are burning fossil fuels. Humans are taking carbon from the lithosphere and pumping it to the atmosphere, okay? And this 1.1, again, this is humans and the effect of land use and deforestation caused by humans. However, something interesting that you can see here is that even if we consider, we sum this 119 plus 0.7 plus 1.1, it's still less than 123.3. So the net flow every year between atmosphere and terrestrial biosphere, it is in the direction of the terrestrial biosphere, 2.3 petagram of carbon per year. The same here, the net flow here is in the direction of the ocean, 1.6 petagram of carbon per year. So you can see here that here we are pumping about 8 to the atmosphere, but about 50% of that is going back to the ocean and to the terrestrial biosphere. This is not without consequences, because this lead to acidification of the oceans, for example, and this has a big impact on tropical areas. But even more important, this 50% that we represent here, that is still is already a bit dated chart, now is no longer 50%. Now is maybe 48, 45. And I checked some data here. I can see here that the ratio, this ratio here, between what is emitted to the atmosphere and what is absorbed by this reservoir. And you can see here that is something that is a quadratic curve. So these reservoirs are starting to get saturated. Their capacity to collect and absorb the excess of carbon that humans pump to the atmosphere is starting to getting reduced. So this is a result from our simulation for French forests. You can take them, it's the same for all temperate forests. You can see here is the carbon dioxide in green is the carbon in the forest, in the living forest. So forests in France are relatively new, so they are increasing, and so they are sequestrating carbon. However, at a certain point, in a few decades, they will start to peak and no longer be net contributor, net absorber of carbon. You can see here in red, this one in red is the carbon in harvested wood products. They don't mean nothing, basically. Even if this is double or 3 times this one, is something that remains very teeny. And this one in blue is the cumulative of the carbon that is substituted. But we'll see later what is substituted, but it's the idea that you don't use fossil fuels if you use wood products or wood energy. And you can see here that this is increasing. So, but they remain small in the short term. So in the short terms, of course, the policies that work better, the mechanism that work better is just to let the forest grow and absorb carbon. However, it is something that is a little bit dangerous, because you do it, but it's like sweeping the dirt under the carpet. When I have friends at my home and I am always constrained with time, I just take and clean very badly, but the dirty remain there. When you will have some wind or something, the dirty will come out. So it's a little bit the same here with carbon. So here the IPCC call this one the fast domain, because there is very high natural exchange of carbon between this reservoir, while the lithosphere is a little bit on a separate part, on slow domain, because you can see that naturally there are very small exchange of carbon from the lithosphere to the other reservoir. So if we do carbon sequestration, we move carbon from the atmosphere to the terrestrial biosphere. However, the carbon is always here in the fast domain, doesn't change. While if we do carbon substitution, we avoid the carbon from going from the lithosphere to the atmosphere. We avoid carbon entering the fast domain. So it's not exactly the same things. Okay. So what's particular on forest? Forest has problem of permanence. We have forest carbon going here, but remain on the fast domain. Then these trees are cut, or the trees are burned because there is a fire. The carbon go back to the atmosphere. There are trade-offs between mitigation and adaptations. There is expensive accounting, because forest sector is not something that is on one place. It's something that is spread over large areas, and it's very heterogeneous. What is forest in one country is not considered a forest in another countries, so it's technically difficult to even describe it. There are some trade-off between sequestration and substitution, so how you deal with carbon mitigation in the forest sector. If I do something, I don't do the other, so I need to choose. And then there are also possible spatial spillover, because, for example, if I say, okay, I put a reserve, a park here, I want my forest to sequester carbon, and I don't touch it, well, we still need wood, so the market will just harvest more in other places. So there are a lot of issues on the forest, to use forest for carbon, for climate change mitigation. So wouldn't it be better instead to focus on carbon tax? Carbon tax, we'll see, are a very efficient way to reduce consumption of fossil fuels, but actually the issue is that climate change mitigation, and in particular carbon tax, cost. And here this message that the climate change mitigation doesn't come free is the key message of the DICE model of William Nordhaus. So William Nordhaus is a natural resource economist that won the 2018 Nobel Prize in Economic Sciences, and the main work of him has been to create integrated assessment models that put together the economic part and the biophysical part of climate change and fossil fuels usage. And by putting this together, it shows which is the impact of climate change on the society, but also which is the cost of mitigate climate change, because in the model you can endogenously come out with the optimal policy, and the optimal policy is not mitigate completely, is not reducing fossil fuels completely now. And the point is that when you do mitigations, you have a cost, of societal cost. When you have a carbon tax, this reduces the utility of people, because it reduces your consumption. So you have a point where a little bit of mitigation, a little bit of small carbon tax, it costs little and produces big effect. But more and more, the cost increase, and the marginal, what we call the marginal effect of the tax in terms of reducing emissions, become lower and lower. So you arrive at a point where you have one optimal carbon tax, you have one optimal mitigations. And the DICE models and this regionalized version, the RICE models, has been highly criticized. But I believe that the critics is mostly in the parameters that has been used, because it come out with optimal level of carbon emissions that is still very high, and we believe now that this is too much high, that the damage is much higher than the one that has been employed in the work of Nordhaus in the DICE. But the concept itself is rock solid. Mitigation do cost. Mitigation has benefits, but mitigation has cost. So you need to find the sweet part where the marginal cost of mitigation is equal to the marginal benefit in terms of the reduced damage of climate change that you apply when you do mitigation. So here I have a chart where I show you, okay, we already saw at the beginning of this lesson that when there is when there is a increase of oil price, there is economic recession. And here is something similar, but when you have an increase of oil price, you have an increase of fuel riots around the world. So there are people that, of course, is not very happy if oil price if increase, and tax would make an effect exactly like this to increase the oil price. And in France we had, for example, recently the Gilets jaunes movement, and very often who is more impacted for a carbon tax is not those that can that are better off in the society, but are those that are most at the need of fuel. They live in a remote area, they need to work, do some work, they cannot do teletravel, they cannot do smart working. They are so increasing oil price by a tax is something that society bear really a cost, and this cost is also not equal for everyone. But there is another issue with putting a tax on oil, and this lead to the fact that carbon dioxide is a global pollutant. Climate change is a global phenomenon, global issue. So if I put a tax, if let's say that there are two countries, there are many more countries, so this is even more true, but let's, for simplification, assume that there is two countries. And if I put if I am a state, and I put a carbon tax, I will bear a cost, a societal cost, due to the fact I put on this carbon tax, and I will have some benefits in terms of the reduced climate change that I have because I reduced the emissions. However, it is very likely that my benefit on me of me putting this tax and reducing climate change emissions will be lower than the cost. However, if we all make this tax, we'll have all benefits, and so here in this example we just make it two countries, but there are hundreds of countries, so the benefits of 100 of countries making climate change mitigation will be much higher than the cost in that country. So we are assuming here that there are two countries, and the cost of climate change mitigation, the cost of putting a tax is higher than the benefits, but lower than 2 times the benefits. And when I put a tax, I give benefits of mitigation to myself, but also to my neighbor, to the other country. So let's go into see, this is called a prisoner dilemma, this framework. Let's assume that I am the first state. So the game is symmetric, so is the same first state or second state. So I am the first state, okay? And I need to decide if put in the tax or not, if mitigate or not. So which is the payoff matrix, which is the benefit to me, the first state, if I apply the tax and the other state also apply the tax. So if we both mitigate, for me, which is the final cost? Of course, I bear a cost, so will be C, but will be minus C, because I have a cost. But I also have the benefit for me, and the benefit that my colleague state also put the tax. So at the end, it will be 2B minus C. Okay, are you with me? Then I don't remember where I put it, but let's say here. What happens if the first state, if I don't apply the tax, but the other states apply the tax? So if the other one apply the tax, I have a benefit and I don't have any cost because I don't apply the tax, so I have only B. Okay. Now let's go into see if I apply the tax, I apply the mitigation, but my colleague doesn't do that. So I have the benefits because I apply the mitigation, so I have benefit arising from that, but I also have cost, so it will be B minus C. And the final situation would be that both me and the other states doesn't apply the tax. So the result, of course, nothing happens to compare, and we keep the status quo, and we don't have neither advantages neither cost of mitigation. Now, can you spot something interesting? So if I need to decide if apply the tax and not apply the tax, I'm the first state. Which would be better for me if the other states apply the tax? It would be better to me to apply the tax or not apply the tax. Because C is higher than B, you can see here that 2B minus C is lower than B. B is higher than 2B minus C because C is higher than B. Okay? So my best things, if the other states apply the tax, would be to doesn't apply the tax. Okay? And what if the other states doesn't apply the tax? Well, this one is negative, okay, for the same reason as before. And this one is 0. So this one again doesn't apply the tax is a better strategy than applying the tax. So you can see here that whatever the other player does, for me, the best strategy is to not do nothing. And this is the same for the other states because again the game is symmetric. So you can see that this solution, we end up both countries to not do nothing, and this is called a dominated solution of this game. And it's what, if there is no coordinations, my interest is not to do nothing, your interest not to do nothing, and it's a pity. It is a pity because this 2B minus C is something positive. So if we could somehow coordinate and say, okay, let's gonna do it together, we would have something, but it's positive, a positive effect of the mitigations. But because here in this game there is no coordinations, the outcome is to do nothing and not put any carbon tax. So this really explain a lot of the difficulties that the world is facing toward making a global carbon tax, and why we still are looking for other solutions to climate mitigation, and why we need climate change mitigations. We need climate change negotiations exactly to override these issues of this global polluter that without coordinations will lead to the different parties, the different governments to behave as free riders. So after these introductions, we can these two. So we had a overlook on the where is the forest sector in the issue of climate change. We have the tools to understand the climate change negotiations. So how the name of this lesson imply, the first event that really is considered at the beginning of climate change negotiations at the international scales is it has been the Earth Summit in Rio de Janeiro in 1992. The official name is United Nations Conference on Environmental and Development. So I was a young teenager at the time, and I can recall really all the newspaper covering this event with special news, with a lot of special editions in the news. And what I want to say is that even at that time, it was felt that was a very important event.
it wasn't something that just passed by. Everyone on the normal people knew about that, and was very important, and very felt. And the reason was that we were in a very typical, very particular situation historically. It was the first major international summit devoted principally to climate change, but not only to climate change, more in general on environmental global issues. And the historical time was particular because we were in a period where we had the first environmental protocol that managed to get successfully approved internationally. I'm speaking about the Montreal Protocol a few years earlier that drew the almost shoot down of chlorofluorocarbons for the depletion of the ozone layers. And then more broadly, there was this widespreading ideas of the possibility for the society to go together and bring and the governance at the global level of the development of the world. So this idea of multilateralism and the Berlin Report, Our Common Future, as well, was few years later. And you can understand the communist world, the wall of Berlin break down few years early. So it was really historically a moment, okay, we can rebuild the society all together and govern these important environmental topics that involve every one of us. So this was the societal point of view, the societal aspect of that time. But at the same time, we started to have also the scientific evidence of climate change being real and being drove by human actions. If you recall the Ansen curves that we saw a few slides earlier with the concentration of carbon dioxide in the atmosphere growing. So this was started in 1958, but the publications has been in 1981. So it started to be know these things behind just a few scientists. And in terms of scientific governance, the IPCC, Intergovernment Panel of Climate Change, has been created a few years early to drive, to analyze, investigate the scientific evidence of climate change. So I would like to I put here a link on a very interesting video. It is in French, I think, so it's perhaps there are subtitles in English. How was the perceptions? It's an interview on the perception of climate change, and these were in 1977. And I put here because it's really nice to see that we have several layers of evidence of climate change and knowledge and about that. So in 1977, so it was really only the scientists that knew about climate change and were starting to worry about climate change, and take several decades to these issues to arrive to the society and arrive to policy action. So here in 1992, finally, it was mature the situations to deal with these issues at the global level and not longer only on a small niche issue in academic sectors. So what happened in the Earth Summit? There are a set of non-legally binding documents that were still important, even if they were not yet mature the situation for them. So the first one is the Rio Declaration on Environmental and Development that bring some principle that again at that time there was just words, they didn't have any practical implications, but it took several decades to arrive and become the foundations of actual policies. I'm speaking about precautionary principle, where you shouldn't look at the average most likely outcomes, but you should also look at when some outcomes may be very destructive, very dangerous, even the probability is lower, you should still put attention to them. And again, here I have a video a few years ago. And then the polluter pay principle from, we'll see that if it speaks only about efficiency, it doesn't matter who pay when you have an environmental issues. It is who pollute that has to pay, or who is polluter that has to pay the polluter not to pollute. On efficiency point of view, doesn't change anything, but on an ethical point of view, this matters, and he's the polluter that has to pay who is being polluted. And again, this one here in Rio in 1992 is just declaration of principle without any outcomes there, and it took several decades to arrive in the loss and damage funds for climate change damage that has been implemented a few years ago in Sharm el Sheikh. Another topic of this legally binding declaration that come from Rio 1992 is this idea of involvement not only of government but also local actions. So Agenda 21 with several subtopics, but the general idea is highlight the importance of local actors. Again, this is something that for several decades in climate change negotiations has been completely ignored, and it landed this idea of society made not only by top government officers but by every one of us, arrived only in the Paris Agreement in 2015 and later on in Glasgow. So again, it took a lot of time. And then another set of principles on forest in particular. So these kind of documents, they didn't have an effect straight away, but there was still an incubator of topics that became then policies later on. What instead become directly legally binding takes the name of Rio Conventions. Against is a set of three agreements. The first two are important for the forest sector because deal with biodiversity and deforestations. But the one I am speaking most of the next slides today is the United Nations Framework Convention on Climate Change. And it is this one that we will deal with for the rest of the slides. So what about forests? Well, it's interesting because, and counterintuitive, a bit paradoxical, that forests remained most of the time at the margin. It wasn't the main subject of the Earth Summit. Even if we were in a forest important place so why was that? Well, you have to think about at that time there was a lot of discussion about deforestation. It was really in the news everywhere, and this idea of deforestation was perceived differently. So it was there was a big contrast between developed and developing countries, because developed countries, they wanted forest to be something preserved. There was worried about the loss of forest ecosystems, while for developing countries there was more this idea of forest resources as something useful for them to develop. So this idea is not something that should be preserved and not touched at all. So it was, and the south of the world was so put under an accusation by developed countries, and there was so this big contrast. It was something sometimes when there is a lot of contrast, it's better not to touch this argument. And so this is where this was the situation in 1992. And then, of course, also was a fact of money, of how much money developing countries should receive by developed countries to protect the forest. So it was at the margin globally at the level of the World event, at the World Earth Summit, and it was at the margin also specifically in the Framework Convention on Climate Change. On the top of what we saw earlier here, another argument specific in the Framework Convention were why we have climate change. What is the main driver? So for developed countries, climate change were there mostly because of burning fossil fuels by developed countries. Developed countries already burned a lot of fossil fuels, and these were the main reason for climate change. And they were worried that developed countries would put instead the cause of climate change to deforestation. So they were starting to find a culprit in developing countries because they are over-harvesting forest resources and then leading to climate change. And then developed countries will say, no, climate change is because you already burn a lot of fossil fuels. So again, this is this idea, this big contrast on development and on specific driver of climate change. And as I said, forests, you have to understand that forests were, the message is that forests were very little involved in the first, in this first phase of climate change negotiations. So, what is the Framework Convention on Climate Change? Well, its objective is to stabilize greenhouse gas concentration in the atmosphere. And you can see here that the point is not to stop completely, but to allow ecosystems and society to adapt to climate change. And we'll see this one also when we saw already. So when we dealt with the issue with the definition of mitigations. So the problem is not only the absolute amount of carbon dioxide in the atmosphere, is how quickly is growing this carbon dioxide and other greenhouse gases. What is important to say about that is that itself doesn't say anything about what states, what people should do in order to solve the issue of climate change. It contains no enforcement mechanism. All that the Framework Convention does is to specify how negotiation from that point on should move on. So which is the way that should be made in the negotiations. So Framework Convention on Climate Change contain no enforcement mechanism, has been approved by all countries. Even US is a member of UNFCCC because it's just a framework, an empty framework, I would say, that doesn't dictate anything about policies. It just say how you should proceed the negotiations. So every year, the members of these framework conventions, they meet, and it's called the Conference of the Parties of the Framework Conventions. And the most important ones are the COP3 in Kyoto in 2012 that led to the Kyoto Protocol, COP18 in Doha 2020 that led to the extension of the Kyoto Protocol that never entered into force. And I'm going to tell you in 1 minute what does it mean entering into force. The COP21 in Paris, of course, the Paris Agreement, and then other one more recent like Glasgow in 2013. So we saw that what has been the pathway from Rio in 1992 to Kyoto in 1997. The important aspect is that the approaches that has been chosen to negotiate climate change, to negotiate the ways to deal with the climate change issues, is to base an approach that is based more on measure which are the flux of greenhouse gases going to the atmosphere, rather than say what each country should do. So the important is that the idea here is that the approach is a result-based rather than an action-based. You don't have anywhere in United Nations Framework Convention on Climate Change and its protocols something that say what each country should do, which obligation should have in terms of actions to do, like creating a new standard for pollution for cars, or a new standard for insulate the buildings. All this is responsibility of the individual countries. The only engagement that country does at the international level is okay, but at the end of the engagement period, how much carbon dioxide you emitted, or how much you removed from the atmosphere. So why this was this? So this was because there was a big push for this result based, because they are more how to say more precise in the results that you obtain. Because when you make an action based, it may be more efficient than what we call command and control. So when you have an environmental issue and you want to regulate that, you have two different kind of instruments. On one side, you have flexible, efficient, market-based mechanisms that say what, for example, which tax you should put for fossil fuels. Great, it's efficient, but you don't know exactly the results. To know the results, you should know the production functions of all the firms and the utility functions of all the consumers. Otherwise, you are not sure that you put a tax, you obtain the results that you want. On the other hand, you have a command and control where you decide that this must be done exactly, this has the result you want, and you do not specify how you do that, but you control that is done. So this other has, you obtain what you want, but the way you obtain is not necessarily the most efficient way. So here in climate change negotiations, in the prevalent aspect has been to go and say, do what you want, but at the end, I want this. In each country, you need to decrease your typically carbon emissions, and these were had support from a large coalition of actors. So the tension was again on the accounting, and not on which institutions should receive states and people in order to obtain better results. And all flexible mechanism that, okay, I do not do that, I emit a little bit more, but I'm doing also this other one to compensate. All these mechanisms were perceived not very favorable. Which are the implications for the forest sector of this idea of pushing for accounting base rather than the actions? Well, unfortunately for the forest sector, accounting is a really difficult mechanism. It's a very difficult science in the forest sector, because we have a lot of uncertainty on the measure. So perhaps we know how much area of forest there is. Perhaps we already more uncertainty. We know how much biomass there is in the trunk of the trees, because there are in some countries there is a good forest inventory. but we know very little of how much biomass, how much carbon there is in the branch, in the root, in the soil. So there is real uncertainty of the measure. And then a second aspect is, okay, I'm engaged to make reductions on carbon, so I'm increasing carbon sequestration, let's say. I'm engaged to increase my carbon sequestration in the forest. Okay, great, but I'm engaged on what? Which is the baseline that I take? Because forest is not something static at one point in time. It's that forest itself has a dynamic, a natural dynamic of growth and hence of carbon sequestration. So what you want to do in here is call it additionality. So how much you push for policies in your country such to change the natural dynamics in order to increase carbon sequestration. But in this case, which is the pathway that you take as baseline is difficult to estimate. And then there are other questions. So this risk of non-permanence that we already saw. So you have a forest that sequestrates carbon, but then it remains there it could go back to the atmosphere very quickly in case of a storm or a fire. And then you plant a forest, okay, but it has a lot of years before it starts to sequestrating a substantial amount of carbon. It has a significant inertia. So objectively, forests were a complex sector to regulate compared with the energy sector, the fossil fuel burning sector, and it remained much at the margin in the Earth Summit in Rio de Janeiro, in the United Nations Framework Convention of Climate Change, and later on in the Kyoto Protocol. So let me, before we see the Kyoto Protocol, let me make a timeline of how a UN convention is made. So everything starts from some organization in the UN that some department of UN that start dealing with these issues and start preparing some draft version of this future convention. This draft version is reviewed by each member states, and there are of course proposals for modification and so on until you arrive in a moment in a assembly in a meeting where this text become final, and finally it is adopted and the convention is adopted and signed. And it's the moment you may see in the news where you have someone, the president of the assembly, have a hammer and say this convention is adopted. It's done. Is the convention, the fact that the convention is adopted means that is effective and everyone that sign the convention should respect it? Well, now you have to think that UN convention in the hierarchy of the law is really the highest level. So even it has prevalence over national law. It's a big engagement for a state to sign a UN convention. So you don't want that someone that is sent there at this big meeting has the power to sign something such important. So what happens that the adoption of the convention simply means that this text becomes definitive, cannot be longer changed, and states just signal their willingness to continue the treaty making process. What happens is that now is that the guy has been sent, the diplomatic or the prime minister or whoever has been sent to the convention, to the assembly to sign the conventions. Now he go back at home, and the way that this convention is the convention is analyzed and approached diverge in the different countries. So in some countries, according to their local law system, it's enough that the prime minister make a decree to continue the process. In other countries, you need a law of the parliament. In other countries, because as we said, UN conventions, international convention is very high is even higher than the constitution perhaps in some countries. It's so high, you want a referendum to approve the same signing of this convention for the states. So whatever happens is what happens depends on the individual countries. So let's assume that this step is passed. So there is a decree, a law, a referendum that approve these conventions. The next step is that after this internal step, the country can finally ratify the convention. So this is the second step. Someone is sent again to the UN and sign and ratify the convention. Okay, what does it mean now? Does it mean that the state that first signed the convention, then went home, get approved and ratify the convention is finally enforced by the terms of the convention? Well, recall what we saw a little bit early with the prisoner dilemma example. If I do something but you don't, I may not be so happy. I may lose welfare or economics or whatever it is. I want you to do it as well. So how can we do that? Well, we can make a system that the UN Convention, even if I ratify, it doesn't become effective, it doesn't come into force until some step happens. This step, what it exactly is, this step is different in the different UN convention. It is in the terms of the conventions. But for climate change conventions, the clause that lead to coming into effect of the convention is that the country responsible of at least 50% of the emissions ratify the conventions. What does it mean? Let's say that Europe is responsible of, I'm giving numbers without sense, 20% of the emissions, and it ratified the convention. It's the first one to ratify the convention. The convention still doesn't enter into force, it remain paper. Then it arrive China, that is responsible of other 25% of emissions. So cumulatively, we are at 45% still paper. Then arrive US, responsible of 10% of emissions, and then we arrive to 55. At this point, when US ratify the convention, we pass the bar of 50%, so the convention become effective for everyone that signed it. Okay, so in this way, we can avoid that only a few ratify and become subject to its terms. So the convention then may have other protocols, and each protocols of this convention follow the same procedure. And it's exactly the case here with the United Nations Convention on Climate Change, where you have one framework convention, and then just each Paris Agreement, Kyoto Protocol, the name may be different, but the Paris Agreement is a protocol of the UN Convention, and they follow the same steps we saw in this slide. Another important distinctions to be made is between these two words, reporting and accounting. Reporting consists of the way that each member of the convention should provide informations on the category concerned. So is how they transmit the data, and this data has to be made in a very specific way. So you cannot say that okay, my forest sequestrated did a sequestration of 1 petagram of carbon. You have to, because you measure in the way you want, you need to follow this some specific methodology that for land use change you see here, good practice guidelines for land use change, and forestry, and this can be also revised in time. So this is very important, and sometimes it's the only legal obligation you have. We'll see that in the Paris Agreement. So it's the way you report the data and the methodology that you should follow to do this reporting of data. Accounting instead refer to the verifications that you do at the end of the engagement period. So for example, engagement period of 10 years. After 10 years, you're going to check that what you reported is coherent with what you promised in the that you fulfilled your engagement for of the terms of the convention. So now we can analyze the climate change protocol. As you can see, the Kyoto Protocol has been adopted in 1997, but it didn't enter into force just until 2005, so about 8 years later. It took a lot of time for for the number of countries responsible of 50% of carbon emissions to ratify the protocol. So the Kyoto Protocol covered emissions up to 2012, and it was then the Doha Amendment that extended the emission up to 2020, with the important note that, contrary to the Kyoto Protocol, the Doha Amendment never entered into force because it has never been ratified by a sufficient number of countries. So the main characteristics of the Kyoto Protocol was to divide the world in two regions. The region in so-called Annex 1, that are the developed countries, that they had legally binding obligations, and all the rest of the world, the developing country, they were invited to do their best, but they didn't have legally binding obligations. So again, there was at that point still this idea of a world divided between developed and developing countries, and the legally binding responsible to reduce climate change emissions has been set only on developed countries. Land use change was, as we said earlier, was very teeny in the whole package, and so it was possible to consider credits from the forest sector and more broadly from land use, but only in a very small amount, only specifically for afforestation or reforestation projects, but not for example, improving the capacity of current forest to absorb carbon. And also, I think it's here, there was a very limit in the credits that could be accounted, and there was no possibility to account for harvested wood products in this quota. So the flexible mechanism in the Kyoto Protocol was, the name was Clean Development Mechanism, and were way for developed country that had legally binding obligation to, instead of fulfill all their obligations directly in their country, but rather buy credit in developing countries. So it was possible only developed country buying in developing countries in order to fulfill this engagement. There are limits on that, of course, and in theory, this could have been possible also for forest projects, but this clean development mechanism at that time has been used very little for forest. Less than 0.8% of projects were forest related, and the reason were that there was several reasons. The first one we just said is because there was no improving of the forest, but was only afforestation and reforestation allowed. The credits were few, allowed, and were complex. They were approved late, but the two main reasons were that on one side it was the developing countries themselves that were not interested in forest projects. At least it was less interested than getting money for other sectors, notably energy, transport, improving, for example, having funds to build railways rather than using the car, rather than roads. So industry, low carbon industry. So they had a preference for this sector rather than the forest sector. But perhaps the main reason why clean development mechanism has been used very little in the forest sector is that they were specifically excluded from credits in the European exchange trade system. We'll see that later in next slides, but the idea is that quickly in Europe there was a mechanism that was creating a demand for this clean development mechanism and at the international level. And Europe itself, so not the Kyoto Protocol, no international regulations, but European regulations will say, okay, you companies can fulfill your company-related obligation, your quota, using clean development mechanism, but no for the forest sector, not for forest projects. And so there was at the end no demand for this project, because the main demand for this project was driven by the presence of the ETS system in Europe. So it was surely very small project, very little used. Still, it was a sort of a seed to gain experience of accounting for carbon in the forest sector. So it has been an experience that helped to more successful projects later on. As the red projects red projects with the plus meaning here in the italic, the red projects deal with and consider also forest, not only afforestation but also improvement in existing forest, and there were projects that deal with forest and carbon outside the main trunk of carbon negotiation. So on one side we have the official negotiation, the United Nations Framework Convention on Climate Change, the COP every year, Kyoto, Doha, Paris, and these red projects, they are a little bit on the side, on a parallel track, but only later on we'll see that in Paris joined the main trunk of climate change negotiations, but originally come from a separate track, and they have voluntary projects, and they are characterized by considering the carbon issue more broadly within more broad topic of development, of sustainable and environmental development. So as I said, there were multiple waves of decision of this red project, and only landed in the main trunk of climate change negotiation in the Article 5 of the Paris Agreement. So if I had to ask you now, you can pause the video if you want. To which reductions carbon dioxide emissions did the EU country engage in the Kyoto Protocol? So the idea here, what the Kyoto and the other protocol put the matter is that, so you have a reference level, is each country how much emissions they made in 1990. So they say, okay, I am France, I am Italy, I engage my country such that we arrive in 2012 and I engage to reduce my emission compared to the level in 99 in my country of 0%, minus 20%, minus 100%, but this is it. I don't have any more emissions, while 0% means I just get the same emission as in 1990. So you can pause the video and try to answer the question. So I'm sure most of you did something around minus 40, minus 60. These were the first time, the first engagement. So it wasn't really so high. The objective were only to reduce for the Europe. The objective were and the engagement were to reduce of minus 8% in 2012 and minus 20% in 2020 with the Doha Agreement. And again, this one exclude for a choice of Europe weren't considering forest, so forest wasn't included in this comparison. So how we do that? This is another important aspect. So all again, the climate change negotiations are international level, are results based. The engagement is not how I do, is what I do. So I reduce emissions. Now, how I do that? This isn't in the international agreement. In Europe, there must there has been some legislation, some instruments that were created in order to achieve to reach this objective. And the main two instruments are the European Emission Trading System, the ETS we was referring to earlier, and for everything that is not covered by the ETS, the effort sharing decisions where forest also is included. So what is the ETS? I referred earlier to two main tools of environmental policy. You make a tax, you have a market intervention, or subsidy in other context. Or on the other hand, you have a command and control. I fix something and I get that one. The first one flexible, but you don't know the outcomes. Second one perhaps more expensive in terms of welfare, in terms of cost for the society, but you're sure to reach your objective. Well, ETS are something in the middle because you first have a component, command and control. You say to the involved sector, you must emit maximum this amount, but of course it should be lower than how it was before. So I give you, you are the company in this sector, you are the firms in this sector. I provide you with allowance, with quota, and this is how much you can emit this year, this year, this year, this year. But then I do another things. I say, okay, you have this amount, this quota, this quota, this quota. I let you exchange them. Okay, so companies that for which are easier because their technology, their specific conditions make it easier to reduce their emissions, they can sell they can do that. They reduce the emission more than they would have done by the quota, and give the quota of pollution to another company for which is more difficult to reduce the pollutions. So here you see that you reach both the objective. You have a command and control, you have a certainty on the results, but on the other hand, you allow flexibility that bring efficiency. The emissions are reduced where it costs less to reduce these emissions. As we said all the time, reducing carbon emissions is a cost. It's a cost for a company, it's a cost for the society. It doesn't come for free. So if you can do that where it is cheaper to do that, of course you bring efficiency. Now, what are the limits of this? Of course, the limits is that you still need to check that, to control that emission, that firms comply to their quota. And you need to set up this market. So it's not something very easy, it's something relatively complex. And you can do that where the emissions are punctual, so in power plants. In power plants, you know exactly how much fossil fuels has been used to generate power. It's easier to go there and check the bookkeeping, accounting, and see if it respected the quota or not. But you cannot do that for a sector where emissions are diffuse, because there is no way that you can go there and check and create a market there. So again, this covers many sectors, but not all of the sector. So it has been implemented in several steps, phase 1 and phase 2 from 2005 to 2012, covering Kyoto. Phase 4 to phase 3 covered the Doha amendment up to 2020, and allowed to more sector, covering arriving to 45% of the emissions. There were no link between these. Something important was these were something isolated in Europe without connection with markets, with emission markets in other countries. And as I said earlier, forestry were explicitly, by a choice of Europe, excluded by the possibility of firms to use Kyoto CDM to, instead of using their quota, buy quota by making projects of reducing carbon emission in other countries, in developing countries. So, which is the effect of the price? How has been the effect of this ETS system in Europe? Well, I don't know if you are surprised or not by looking this chart. This is the price, because it became a commodity, financial instruments, and it has this quota, this allowance have a price, and this price, as you can see, has been close to zero for many years, and only more recently it increased. What does it mean? It means that these allowances were too much. There were too many allowances, and they become mostly useless because all the company managed to keep their emission up to this allowance very easily. So now you say, why the EU has created this giant system, very complex system, if at the end the results has been very minimal because there were too many quota. And I think this has been a bit intentional, in the sense that very often when you want to politically introduce a new instrument, a new constraint in the society, in the life, in the that go to alter the business of companies or the behavior of people, it's not easy to get it approval. So one strategy is to get the instrument approved, but make the way that this instrument doesn't create much constraints, doesn't contain much trouble for business or people. And only later, when the instrument get already operational, you start little by little to make it more constraints. And I live in France, and a clear example of this is the restriction of pollution cars to enter the cities. So there has been a big debate about this in France, and because people need cars, people can't afford to buy new low pollution cars every third year. So something that has been made is exactly the same logic of here the EU ETS. I'm going to create the instrument. I'm going to create this area that have a restriction for polluting cars. But then I'm going to create so many exceptions. So I'm putting the limit so high that Euro 1, Euro 2 cars can still enter and so on, because it doesn't matter. Still, I get it approved as an instrument, and later on, with time, gradually, I will close the gap and make only green cars be able to enter the city. And that's exactly the same what happened here. First, I make the instrument, so for many years, I don't put pressure on the number of quotas I provide. I give free allowance. I don't make companies pay for that to get the instrument approved. And only you can see after 10 years or so, I push it, the limit, the bar. I raise the bar in order to have an effect of my policy instrument. If we speak more in general, which has been the effect of Kyoto? Well, good question. There are two, as I said, there are the Kyoto Protocol were dividing the world in developed and developing countries. Developing countries no obligation, developed countries obligation to reduce the carbon emissions. And if you see here, if this chart show the share of carbon emissions by country and time, and you can see that at the beginning, the most country in last centuries, or the beginning of last century, the most pollution, most carbon emission come from European Union and US. And the rest of the world were very few, produced very few emissions. But as the time passes, you have more and more emission coming from the ex-developing countries. So one could say these were a spillover effect. So polluting industry moved because of Kyoto from developed countries to developing countries that had no obligations. My point of view is that instead these were a structural trend that happened well before the Kyoto Protocol. Of course, there is no counterfactual. We don't know how the world would be without the Kyoto Protocol, so nobody can see that, can say that. However, really you can see that this trend was already in place. So my hypothesis were that it wasn't Kyoto the responsible of this shift in emission toward developing countries. So if you skip the Doha agreement that is on the same line of Kyoto Protocol, but just extend the reference period, the next major agreement has been at the 21st Conference of the Parties in Paris in 2015. We are still, I recall you, within the framework of the United Nations Framework Convention of Climate Change, just another protocol of the convention, even if the name is not protocol. Here, the main objective is to keep the increase of temperature well behind 2 degrees, with all effort made to keep it at 1.5 degrees. So, which are the difference between the Paris and the Kyoto Agreement and the Kyoto Protocol? Well, the main difference is that we are taking a much more bottom-up approach. There is no longer some big table, big engagement, big discussion where each country is assigned a commitment. But here, the stress is on each country to provide a proposal on what they can do in terms of reducing carbon emissions. These are called nationally determined contribution, nationally because it's each country that decides what it puts on the table, what it offers. And these nationally contributed, they are not one-off, but they are something that is kept and is reviewed every 5 years. So the first year has been in 2015, the second one should have been in 2020, 2015 plus 5, and then so on every 5 years. The first NDC that has been proposed in the Paris Agreement were very far from reaching the objective of keeping the world at 2 degrees increase in temperature, because it was around 3 Celsius degrees. But later nationally determined contribution with this idea of keeping and reviewing them every 5 years could go to the topic, to the objective. The important things, there are two very important things in the defense in Paris versus Kyoto. The first one is that we no longer have this distinction between developed and developing countries. Every country has to submit NDC, but you remember when we spoke about reporting and accounting? Reporting here is the key. Only reporting is the legally binding part of the agreement. You propose to reduce 10%, you have to report your emissions, but if at the end you reduce your emission of 8%, I say, instead of 10%, nothing happens. So it's a bit is an engagement that is not an engagement. It's an engagement that you offer this to the international community. However, there is no legally binding mechanism to sanction you if you don't reach your target. And why is that? Because at the end, it's still hard to punish a country not to reach, not to fulfill their obligations. So at this point, just make it clear, it's not an obligation. However, it remains like sort of soft power, if you do not respect your obligations, I can still see in the documentation that you didn't bet, so I can still blame you for not having done that, but there is no punishment, no official legally binding punishment for not reaching your obligations, your promise. And another thing, this NDC leads to much more flexibility, because they can have very different forms. They can include forest, they cannot include forest, they can have different forms. Later on, there has been more standardized this form, but you understand in 2015 there was a little bit of a rush, so each country proposed something, and this something were a very different level. So the idea is, compared to what it could have been, the agreement is a miracle, because we were coming from a situation where there were no climate change agreement. Doha were never ratified. So finally, now in 2015, we have something that has been accepted by the world community. However, the fact that it's not legally binding, the fact that these are not sufficient, the initial NDC, to keep the world at 2 degrees, led something to say that compared to what it should have been, it's a disaster. The equivalent of the clean development mechanism, it changed the name, but it's the same substance, is the sustainable development mechanism, and it has the possibility to trade mitigation outcomes with some differences. The first one is that it's no longer between the developed buying these in developing countries. And also, we see that in a slide dedicated, this Article 6, because it's the flexible mechanism that has been the most difficult part to solve in the Kyoto Protocol. It took a lot of years, and only has been solved has been implemented, let's say that, in the COP26 of Glasgow. There has been other Other part, the finance part had an important role, and the forest here enter much more the founding and the negotiations. So forest was a lot part in of the Paris Agreement. You recall that slide where we saw that carbon sequestration, carbon removal were the word removal were present 9 times in the agreement. There were really this idea of the necessity of using the forest sector to remove carbon from the atmosphere, and the RED project enter into the Paris Agreement. Transfer of green technology also is given to developing countries. Okay, this one I already said it. So again, the important part of this of the Paris Agreement were to mandate the reporting of the emissions in each countries, including the forest sector. And of course, this has to follow specific methodologies. So what about the withdrawal? You know everything. The story of U.S. First with Obama signing, then it arrived Trump and push U.S. down, and then arrive Biden and put it back. So for that period, in the reality, because the withdrawal was possible only after 3 years from entering into force, and it was taking 1 year to withdraw. The actual withdrawal of the US, the first withdrawal of the US from the Paris Agreement was barely a few months. It was insignificant. What is true instead is that the second withdrawal with the second mandate of Trump, these were much more important and effective. So as I said, Article 6 is it is the part of the Paris Agreement that took longer to get implemented, and it contained 3 different mechanisms: country-to-country emission trading, so facilitate the trading of emissions; an international carbon market for the private sector that again it's only here in Paris that the private sector start to be involved in the international negotiation, and not only as in the local regulation, in a local legislation that is made by the different countries in order to fulfill the international agreements. And then there was something more broad about a non-market approach that there was a bit of blah blah blah. Again, there is different interpretation of this Article 6 because it can bring flexibility, but it can also bring loopholes, a way for countries not to really fulfill their agreement. And as I said, one important difference is that while Kyoto were top-down, so first there were the international treaty, then the EU level legislation, then national level legislation, then perhaps regional implementations, for Paris it happened at the opposite. So first there has been a regional, national, and EU regulations that paved the way for EU to arrive there an international treaty with some offer to put on the table and sign the international treaty. So same question as before. Here in Paris, to which reduction of carbon dioxide emission did the EU country engaged in the Paris Protocol? I recall it was -8% in Kyoto, -12% then in Doha. Okay, so the target for 2030 was -40%. The original was -40%. So in 2030, reduce their emission of Europe such to arrive to -30% of the level of 1990. And this again is is implemented through using two different instruments. On one side, ETS that has to provide minus 43% in 2025, and everything else that has to provide a 30% reduction in 2025. And here, everything else is, you can divide it again in two main things: agriculture, effort sharing, including agriculture, and land use change on and forest. And for agriculture, you have minus 30% of objective, and for the forest sector, you have a no debt objective. So you don't have a specific objective to improve sequestration, but at least you shouldn't create a debt. And you can see here you have some arrows here, because you can take some countries can take some of the allowance here. If, for example, agricultural perform better in a certain countries than minus 30%, you can use this saving of emissions to the forest sector, but and you don't have any constraints on that. But on the opposite side, if your land use change, your forest sector perform better than no debt, for example, you are increasing your forest, so they are sequestrating more, you can use some of these bonus in a certain way to the agricultural sector, and you have a maximum of 280 millions of ton of CO2 equivalent. Now, why do you think that from agriculture to forest, full flexibility, while from forest to agriculture, you have a cap? Well, it's clearly because agricultural is one of the most difficult sector to decarbonize. So the fact there is full flexibility here is because the legislator know that these were not used anyhow. There were no way that you do even better in agriculture, and then you can harvest more in the forest sector. Conversely, the other one is real. So there are some countries that have a lot of forests, and their forests are growing fast, and it's easy for them to have credits in the forest sector. So it's there that the legislator put a cap to say, okay, but this doesn't mean you do nothing in the agricultural sector. And these are the original objective, but this has been revised here. I put the quotas in the revision in 2018, but there has been further revision, but we'll see later. So what about Paris and the forest sector? As again, the forest sector in Paris were very present, very part of the engagement of the different countries, and arrived to it's estimated that 1/4 of the total contribution of the various countries refer to the forest sector. And this is because, again, is to counterbalance what is unavoidable. Some emissions you can't stop. So you need to have another way to counterbalance these emissions. And as said, big responsibility. I like Spider-Man, because with great power come great risk, and things could go wrong because countries could decide not to implement their own promises. The current promises may not be sufficient, or perhaps we believe that they are sufficient, but they are not, because we don't have complete knowledge of the Earth carbon cycle even today, and the effect of climate change. And what started in the RED Plus project to consider to consider climate change as just one point of one issue of a more broad issue of development, here you start to feel it in Paris, where climate change becoming an umbrella that link all other forest policies. rather than be an isolated policy. After the first COP after Paris, or the first, no, sorry, not the first COP, but the one that were supposed to pave the way for the Article 6, where the implementation of Article 6 were Madrid, and where the year before 2020, where the national determined contribution should have been revised with the second wave of them. And the fact that this nationally determined contribution should improve it, it's were really the matter of the decision of the Madrid COP, because the text approved at the COP is, it recalls that new climate pledge should represent a progression behind previous pledge and represent the highest possible ambition. You can read here the word should. Should is not a mandatory legal term. So if instead of should would have been shall, legally means they have to improve. So I made a nationally determined contribution in Paris in 2015. I made another one in 2020. If the word approved here would have been shall, means that I am obliged to improve them. Why it's a should, how it has been approved here with this word here, means that we invite you to improve them, but again, we left up to you if you want to approve them or not. So how the EU prepared the way to this second wave of a nationally determined contribution in Glasgow? It did that through what is called the EU Green Deal, that is a set of policy homogeneous between them, but a set of interlinked policies at the era that there were a new EU Commission President, Ursula von der Leyen, and the idea were really to push the EU economy to a low carbon economy, and introduce something that were first it revised the objective. So here we are, it was minus 40% originally in Paris, so in 2030 compared to 1990. Now the objective increased, so we are reviewing this nationally determined contribution to make them a cut of 50% of the emission of 1990 and arrive to what is called net zero emission in 2050. But is this idea that, okay, I kept only few emissions that are not, that I cannot stop them, but at the same time I remove an equivalent of these emissions through typically forest project, so that I arrive to a net zero emissions. What is important is that this is implemented in legislation rather than just in policy declaration, and is one of the very few that are implemented as legislation in the world. There were a lot of funding, new reference level for the forest sector. So after that, we are in 2019, how this big shock that happened at the COVID crisis, the Ukraine war, the trade war, the Iran war, how these crises affect this policy is an important topic to assess. You can see that the main question is if all these shock affected the mitigation of climate change in positive, that is helped to arrive on quicker mitigation, or in negative, that it means they make mitigation more difficult. And not there is no consensus on this topic, because here I show two papers that say the opposite things, and the idea is that this shock make us there is a short terms and a long terms effect of this shock, and in general, all this make us a little bit less rich, and this has implications that could go in one way, less consumption of fossil fuels, so helping mitigations, but also could change our behavior, and not necessarily in positive. So here is a example of an environmental, this is the from my master thesis, the environmental closeness curve, that is empirical law, with all the duct of empirical law, but at least that we discussed earlier. But at least here we have some motivations of this law, and this idea is that when a country become richer, where the gross domestic product per capita increase with economic growth, we have first a phase where this increase lead to higher pollution, but then reach at a certain level, what happens are our indifference curve, our preferences. So when we are poor, we don't care about the environment. We care about physical goods, and but as we become richer, more and more our preference go toward a clean, safe environment, and this lead to a reduction of the pollution. So if we have an economic crisis, the effect will be to reduce, or at least not to increase as much as if the crisis would not arrive, our economic situation. And so with a reduction of the GDP, or our reduction of how rich we are, it changes also our preferences. So we don't care so much to the environment, and we care back to other issues. And this was clearly, and the COVID clearly showed this one, and the Ukrainian war as well, when the focus has switched from let's gonna be green, let's gonna make the EU green, and make Europe very very good without carbon pollution, to a situation where this policy has been put a little bit on the side to favor other policies that were more topical. So let's say that we arrived in 2021, where that originally was 2020, but has been postponed for the COVID, and with not officially to see the result of the US election, so that these discussions could have been made with the new US president. And we arrived in Glasgow at the COP26, where the main outcomes is called the Glasgow Climate Pact. And the main, okay, so this in this Glasgow COP, the objective were to revise the nationally determined contributions, and it has been done that with the knowledge that climate change was already there, because just a few months before the conference has been released the sixth assessment report, where main difference with the previous one is proof that climate change is not something coming in the future, but it's something that is already here with us, with the fact already here with us. Nevertheless, a bit, for me, hypocrisy, with a little bit of hypocrisy. The objective declared in Glasgow were resolved toward the increase of 1.5 degrees Celsius increase, that is basically impossible. And the goals, the overall goals has been to reduce carbon dioxide of 45% in 2030, And I think there's an error here. It's not 2010 level. It's 1990 levels in 2030, and arrive on net zero for all the globally for all the world in 2050. Something that I can recall about Glasgow is really the last moment, moment of the conference where there has been a push toward making finally a declaration of phase out of fossil fuels. This didn't happen. The official text of the Glasgow Climate Pact put only in the text the phase down of coal and I remember again the president of the Glasgow COP very upset about this because of course it's something that is really trying to push phasing out of fossil fuels, but we are not yet there, and we are not there in Glasgow. What is phasing out instead are the subsides that still exist to the production of fossil fuels. The finance target has been increased, and as we said in the previous slides about the Madrid COP, the nationally determined contribution effectively has been updated, and the cycle has been changed from 5 years update to a yearly update of the nationally determined contributions. And again, there is there is a push to arrive to a net zero in the long range. I skip all this about the fact that these nationally determined contributions start to be more standardized compared with Paris, where they were very broad. Here, yes, this is the slide I wanted to arrive. So here you can see by each country the variation of nationally determined contribution in Glasgow compared to Paris. So by country and cumulatively. So here, when you go orange, it means that this country has improved, not much. For example, in Argentina, it's improved a little bit compared to Paris, but then Australia did nothing, and Brazil change of policy of government, it did the opposite. So it is not an improve compared with Paris, but is a regression. And again, this has been possible because in Madrid it has not been there has not been an agreement to the stronger English word shall, and so it should, but not for everyone, like Brazil show. However, you can see here the majority of countries did an upgrade, except very few one that you see here. At the end, we had a substantial improvement in Glasgow compared to Paris. Something on the line of what already started in Paris, the topic of climate change started to become broader and not consider only climate itself, but consider development more broadly, including also different agents, not only the state agents, but local actors. And it has been, in particular, the Article 6 of Paris Agreement finally in Glasgow has been implemented, because in the Paris Agreement it's a very short general text that needed an implementation that arrived in Glasgow. So in Glasgow, we know climate change is already here, and is the first COP where the possibility of a fund for loss and damage is put into the discussion. So it's not yet here, but it started here in Glasgow. This idea that started in the Earth Summit in Rio de Janeiro with this polluter pay principle finally arrived in Glasgow and then in Sharm el-Sheikh to be implemented. Concerning the forest, there has been a specific document to revert deforestation, but deforestation causes carbon emission in the atmosphere. And what is interesting is that here is the first time that it's not only blah blah blah, but this policy document comes with some funding. So there is hope that this could be implemented. After Sharm el-Sheikh, after Glasgow, the next COP, as we said, has been in Sharm el-Sheikh in Egypt, and its main outcome is finally this implementation, even if it's without fund yet. Next COP arrived the founding of these loss and damage funds toward countries that already suffered the climate change, but is already here. And again, there has been a try to push this phasing out of fossil fuels, but no, we are not yet there. There is another formulation, but push for renewable, but not yet phase out of fossil fuels. We arrive to the much discussed COP of Dubai, because I feel a little bit strange. You are making a COP about reducing fossil fuels, and then you do that in a country that depend on fossil fuels. And there has been also some not very nice story about that. But again, there is no phase out of fossil fuels, and there has been the first implementation of the funds for the loss and damage fund that has been defined in the previous COP. So the latest EU package, if we go switch back to a European perspective, the latest package in Europe concerning climate change mitigations, the latest implementation, how we do in Europe, how we fulfill our international engagement, is the EU Fit for 55 package that has been adopted in 2023. And if you recall, the latest slide were minus 50%. Now the latest value is minus 55%, so a marginal increase. And this will be done by revision the EU ETS and creating a separate ETS2 market for building and transport, with the difference that is not the final users that have the quota, but is because you cannot control is a diffuse buildings and transport are a diffuse sector, but are those providing fuel to building and transport that will manage the quota. And also for what concern the forest, if you recall the slides with where there were the arrow between one sector and the other, there the forests were no debt rules. Now it's improved, and the forest, the latest objective put that each country should have an advantage of the forest. The forest should contribute as well to these mitigations with at least 310 million of tons of CO2 equivalent. Which is the one new instrument that has been, so the idea is, okay, if I am the only one putting a tax, if I am the only one to do the effort, my economy will suffer, because and it will not be very effective, because I'm only delocalizing the pollution somewhere else. So the idea is, okay, I put ATS system or in place, or a tax in place, okay, but I do also another things. If this product I tax for carbon this products or this sector, I also tax this product for the amount of carbon that is embedded in the production of this product, and the difference between my taxation, my carbon tax, and the carbon tax of the country that is sending me that is exporting to me the goods. This recall me a little bit some the new open source software license. The new license say that you can make open source, but after you make open source, everything else need to made open source as well, with that if you want to change and produce something else with that software. And it has been let's say accused of being a sort of cancer, because it contains it's forward this idea of open source software. And here is the same mechanism. So I am the consumer, Europe is mainly consumer of these goods, and I force you to make a tax, carbon tax like mine, because otherwise I charge you on the border. I charge you a tax on the border, a custom tax on the border. And this incentive you to apply the same carbon tax. So the EU carbon border adjustment mechanism for the moment is, for now, it covers a few carbon intensive sector like steel and cement. And it's very recent, because it's true that is in place since 2023. However, up to the 1st of January, after 31 December 2025, it has been only reporting without the actual taxation coming in place, and it's only from 1st of January of this year, 2026, that firms need to pay this custom tax. And this list of products is expected to increase with time. We go to the latest two COP. In Azerbaijan has been a controversial again COP, and very transitional with very few outcomes. We already knew here there is the new US administration, so the focus has been more on investment rather than making new nationally determined contribution, with the idea that investment could have been something more palatable to the new US administration. And finally, we arrive to the latest COP at time of speaking in Brazil in latest November. And the idea here were, unfortunately, to arrive back, there was a lot of hope for the COP. The idea was to close the loop, arrive after 30 COP in Brazil, where everything started, and arrive with some declaration, with some clear objective to phase out fossil fuels. And it didn't go so well. There were different administrations in powerful countries, important countries. So at the end, it has been not a very important COP. And with this idea of forest, to preserve forest, but also possible use of biofuels from as a renewable resource from the forest. So you can see here that really depends a lot. Policy is important, because here this chart show the deforestation, the flux from land use change, to be more exact, in different countries over the years. And you can see here the very high variability from 1 year to another, and it's really depending on which political side is in power in the country in that years. So the next COP will be in Turkey, but it will be the first COP that is co-hosted by two countries. Physically, it will be in Turkey, but the organization is delegated to Australia. So where are we? Where are we with carbon dioxide mitigation? How we are here with climate change? Well, we have a lot of effort in international negotiations. What we didn't saw is that aside of that, there has been a really technological push toward renewable resource that doesn't impact climate change. You see the price of solar in 10 years declined by 89%, and to a lesser extent, but still strong, the wind also has steadily decreased. So in a certain way, this idea that the Stone Age didn't end because of stones is this quote is really reflected in this chart. This idea that new technology can arise, perhaps can arise quicker than political negotiations. This chart as well show the strong growth that has been in the renewable energy, and here as well the power capacity expansion, to say that in the latest year really the expansion of new power plants, it's really the 93% on renewable. So there are very few power plants that are made with non-renewable resources. Now, renewable resources often has a problem, is the intermittence. So it's important also to add a way to stock this energy and allow to supply to align to the demand of energy. And here is a chart of the expansion of global battery storage. And another one here we have for hydrogen. Hydrogen is for the really most a source of transport and storage of energy rather than itself a form of energy. And can be storage of hydrogen. There are a lot of plans at the national level here in France for making really high capacity of storage, because clearly there is a difference in temperate in temperate countries between winter and summer. So hydrogen is the only form that can store very large amount of energy between seasons. So, which is the perception of climate change, the public perceptions? It's really changed, and it's really depend on time, if we are close to an event of an important COP or not, but also geographically. And you can see here that the countries where that are more impacted by climate change are also those, of course, where discussion of climate change is higher. And I think that our role here in the economic sector is to better understand the issue of climate change, the actor involved, and help them to speak between them, and because we don't have all the same expectations. So my next few slides, where are we? So this chart show the carbon dioxide emissions, and show which would be compatible, which are the pathways that would be compatible with keeping the 1.5 degrees. So if we would have started here around 2000 to stop carbon dioxide emission, it would have been sufficient to do that in a very smooth way, to follow this curve. And if we would have done that, this curve would have led to 1.5 increase. Did we do that? No, we didn't. So our emission continued. So if it was in 2010, we should have followed this curve. We didn't. No, they increased and increased, and you can see now that if we want to do it now in 2026, we would have to follow this curve to stay to 1.5 degrees. So you can see really that time is very important, that short-term matter, and forest sequestration we saw has an impact only in relatively short terms, but still the fact that we have a threshold effect, reversibilities in the climate systems made this fact that even short term, even by a few decades, by using forest to improve carbon mitigation is something that is not completely stupid to do. Sorry if I use this word, because short time is very important. However, forest, it's difficult to say to use forest because forest is already impacted by climate change. Here is this photo are in the Vosges Mountains in East France, and you can see how they has been impacted by climate change. And this it's me. I take this photo by walking there, and it's really impressive how these mountains that are not very high, so they are small mountains full of coniferous, and these coniferous forests are no longer adapted to this area, and forest has been impacted a lot by climate change. So what is this curve? What is this curve? Our conclusion for today. You can put several things here. One thing that I would like to say is that forest as a cause and solution of climate change. We saw in the early climate change negotiations, forests were completely put aside. Then we arrive in Paris in 2015. Forests become the main way to solve climate change, and we arrive more recently to recognize that forest, okay, we may help, but forest has its own problem that derive from climate change. So perhaps this is the perception of forest of climate change. However, this is also another things we saw with the environmental closeness curves, that as we become richer, we decrease our emissions. So perhaps it's true that climate change shouldn't be a completely isolated policy. We should think to any policy that increase development and increase poor people to get out of the poverty, and in order to change their perception of their preferences of climate change. So this is really something that is our job as our ethical, that is ethical aspect of climate change, that we cannot think to obtain climate change till climate mitigation, until we kept a large part of world population in poverty. So thank you for listening to these slides, and I put here some bibliography here, some references, and I invite you now to answer a small quiz to recap all this long lesson that we had together. So let's starting. This quiz is made with a tool that I normally use in my class interactively. So the students go to this website and put a code and they play with this answer. Now on the video, you can just answer. You can just stop the video, get your time, answer the question and then I give you the correct one. So let's start. The first question is related of how much energy, how much is the variation between the energy that enter from the sun to the earth and how much of this energy leave, which is the imbalance, energetic imbalance. So compared to what it enter, how much of energy leaves the space to the space each year, so 30% less than what enters, 0.3% less than what enters, or 40% more than what more than the energy that it enters. You can pause the video if you want. So the correct one is 0.3%. Of course, if 30% less of the energy that it enters go to the space, we would be burned in a few days, I guess. And so it's only enough 0.3% of this energy imbalance to cause the climate change issue. Let's go to the next questions. Of all greenhouse gas emissions that come from human activities, how much come from burning fossil fuels? About 25%, about 45%, or about 65% of all greenhouse gas emissions from human activities are due to burning fossil fuels. You can stop the video. So the correct answer is 65%. So really burning fossil fuels is the main cause of climate change. Atmospheric CO2 concentration has never been this high in Earth history. Is something true or not? You can pause. It is false. As I said during the lesson, the Earth had higher concentration of CO2 in the past. We need to go very far in the past, but this is true. And also was warmer than today. What is really unique in climate change today is the speed of change, is how much quickly carbon concentration is reaching the atmosphere, how much quickly the world is warming up. Climate change is not a new phenomenon, as the Earth has always experienced a significant temperature fluctuation. True or false? You can stop the video. It is false again, the same things. It's true that has always experienced fluctuations, but climate change is a new phenomenon because this fluctuation has never been so quick, so rapid. In recent decades, the ocean has accumulated 91% of the total energy accumulated in the climate system, Earth energy imbalance. Is this true that this difference, 0.3% of energy coming to the Earth more than what is leaving, 91% of this energy has been accumulated in the ocean? Is this true or false? You can stop the video. It is true. So we need to say thank you to the ocean for two reasons. One, because they are absorbing the imbalance of carbon dioxide to the atmosphere. So we push carbon dioxide to the atmosphere. We are making these things very excessive of carbon dioxide in the atmosphere. This partially, about 50%, is going back to the ocean and the terrestrial biosphere, and this is one mechanism that we have to say thank you oceans. And the second mechanism is that for what carbon dioxide remain, this create a energy imbalance, but 91% of this energy imbalance is covered by the ocean. So the oceans are the sector of the Earth that are keeping the most of this energy. While adaptation refers to action aimed at reducing the hazard component of risk, mitigation concern action related to reducing exposure or vulnerability. Is this true? Pause the video. So it is false because it's the opposite. I recall you that we can decompose risk in hazard, the probability that the event possibly dangerous arrive, and then vulnerability and exposure and vulnerability. And mitigation is the part that tries to reduce this likelihood of the event coming, of climate change arriving as event. And adaptation is instead all the actions that we can put in place in order the conditional to the event coming to reduce our exposure and our vulnerability to that, and perhaps take the most of what is possible given this climate change already being here. At current consumption level, fossil fuel energy reserves are estimated to last only a few decades. Is it true or false? Well, it's false, but is not well said. It's false in the sense that we know that there will be discoveries and these reserves are increasing with time. But it's true if we say that currently the estimated is valid for a certain decades. So it's a bit ambiguous. I shouldn't make it formulate in this way. But the message here is that even if you say current reserves are for estimated to last for 50 years, we already know that it's only a measure that is now, but future discoveries will, future improvement of technology will make this reserve much higher. And the idea is really fossil fuels is not a problem of scarcity. If France reduces, or Italy or whatever, reduces carbon emission by 10%, the benefit to the country in terms of reduced climate change damage will be approximately 5%. It is true or false? Pause the video. It is false. It's much less than 5%. This is why we cannot do that together alone for mitigation, because if mitigate make a cost, there is a cost of mitigation in each countries, but the benefits of our action, our mitigation for ourselves, it's much lower. It will be 0.01 or 0.1. It's only when all countries around the world mitigate that we have an overall benefits of mitigation that is higher than do nothing. The social cost of carbon is the discounted present value of the net damage to society from emitting one additional ton of CO2. Is this true? So the idea is social cost is the definition of social cost of carbon, the cumulative discounted present value of all the damage that carbon is emitted of the carbon that we emit now to the atmosphere. Is it true or false? Well, it's true. It's the definition of a social cost of carbon. So that is the one we need to consider when we do mitigations. At the margin, one action, one additional action of margin of mitigation, does it cost more or less than the advantage it gives us in terms of reducing the damage of climate change? And in order to do this assessment, we need to compute the social cost of carbon. The acronym COP stands for Conference of Procrastinators, I love this one, Conference of the Parties, Community of Practice, or Calculator of Pollution. So I don't tell you to stop the video here, you know the answer, I hope, by now. China's total CO2 emissions have surpassed those of the US in 2005. since the entry into force of the Kyoto Protocol. Is this true? It is true. Yes, it is true. But again, this is not necessarily linked to the Kyoto Protocol. It was a structural trend that were already in place. How many of the 195 recognized countries have adopted the Paris Agreement on climate and environment? So how many countries adopted the Paris Agreement? 92, 142, or 192? Stop the video. It's 192. So these were the big success story of the Paris Agreement. All countries in the world except Syria, because there was the war, and Nicaragua, because he wanted to do more, adopted the Paris climate change, the Paris Agreement. And this reflected by the fact that it has been ratified very quickly compared with Kyoto. Emission trading systems combine the efficiency advantage of Pigouvian taxes with the outcome certainty of standards, of environmental standards. Is it true or false? Pause the video. Yes, it's true. As we said earlier, we have these two main instruments for environmental policies, the tax and the command and control tools, the standards, and the emission trading system combine the advantage of the two. Still, we have some disadvantage, the fact that they are complex, the fact that you still need to check that the firms produce according to their quota. The Glasgow Climate Pact, adopted in 2021, includes the phase out of fossil fuel subsidies. Is this true or false? Pause the video. So it is true. Recall you that the objective was the phase out of fossil fuels, but we didn't go there. We did only phase down of fossil fuels, but at least we had phase out of fossil fuel subsides. This year COP was held in Dubai, COP 30 2025. Is true or false? Pause the video. It's false. The COP 30 were in Belém in Brazil, and these two COP before that were held in Dubai. The price of electricity from solar PV, including capital cost, declined by 89% between 2009 and 2019. Capital cost is the fact that basically the running cost of solar PV is almost zero. What it costs is putting the system in place. Is true or false? Pause the video. Yes, it's true if you recall the chart that I show you during the lesson. It's crazy. Worldwide, more electricity is still produced from coal than from renewable sources. It is true or false? Pause the video. Okay, here I don't remember what I put. I think I put true, but it's tricky because we have data only for the last semester. So it's false. Sorry. In the last in the first semester of 2025 is the last period we have data, and the first semester of 2025 has been the first time where we had more energy arising from renewable resources than coal. We don't yet have data for the whole year 2025, so I cannot give you for sure, but it's likely that being the first semester, also the second semester, because the trend is clear, we had renewable resources taking the lead on the energy production, on the electricity production. Hydrogen is an almost limitless clean energy source, but it requires substantial investment. Is this true or false? Pause the video and answer. So it is false here. It is false again borderline, because it is absolutely true that it requires substantial investments. And if we take a perspective, we can also think that this is really recent as hydrogen as a energy source, natural hydrogen existing on the Earth. Up to now, and hydrogen is only a source of where to store and transport energy. But in order to produce hydrogen, you need to push energy, for example, from the renewable energy. But it's something that may change in the future. So I'm done with this quiz, and I thank you again to your time to listen to this lesson, and good luck for your studies.